Hello friends, welcome in Pharma Talks. I am Arpit Pandey and the today's topic is chromatography. In this series of videos we are going to discuss all about the chromatography. So starting from the basics. So what is the chromatography? Why its name is chromatography? Who discovered the word chromatography? Now started. In history, the scientist known as Michael T. is a Russian scientist who was born in the 1872 and died in 1919. He is a botanist by profession. In 1906, T. used to chromatography to separate plant pigment. Why its name is chromatography? Chroma means color and graphene means to write. So anything we have to write with the help of colors. So according to this, he named their technique is chromatography. He called the new technique chromatography because the resolution of analysis was written in color along the length of the absorbent column. Okay friends. So importance: chromatography has application in every branch of the physical and biological science. And today 12 Nobel Prizes was awarded between 1919 to 1970 alone for the work in with the chromatography. So at current 12 Nobel Prizes was awarded for the work in the chromatography section. So you just think how vast topic it was. So chromatography. What is the chromatography? Chromatography is a physical method of separation in which the component to be separated are distributed between two phases, one of which is stationary phase, while the other, the mobile phase, moves through it in a definite direction. The chromatographic process occurs due to differences in the distribution constant of the individual sample component. Okay. So chromatography is a technique used to separate and identify the component of a mixture. Works by allowing the molecules present in the mixture to distribute themselves between a stationary and mobile medium. Molecules that spend most of their time in the mobile phase are carried along faster. So classification of chromatography according to the mobile phase. If we talk about the mobile phase, so classification is based on the mobile phase. So as per the mobile phase classification, it is classified into two phases. One is the liquid chromatography where the mobile phase is liquid, and the second one is the gas chromatography where the mobile phase is gas. For the liquid chromatography, you can take the example of the HPLC, and the mobile phase where gas is used, you can take the example of the technique GC, gas chromatographic technique. Okay. Classification according to the packaging of stationary phase. So the classification is based on the packaging of stationary phase. It is classified into three categories. The first one is the thin layer chromatography. The stationary phase in a thin layer chromatography, the stationary phase is a thin layer supported on glass, plastic or alumina plates. Paper chromatography. In paper chromatography, the stationary phase is a thin film of a liquid supported on an inert support. And the third one is the column chromatography where the stationary phase is packed in a glass column. Okay, friends. So next, classification according to the force of separation. So as per the force of separation, it is classified into five categories. The first one is the adsorption chromatography, second is the partition chromatography, third is the ion exchange chromatography, fourth is the gel filtration chromatography, and fifth is the affinity chromatography. Okay friends. So now we have to discuss what is a thin layer chromatography. Thin layer chromatography or TLC is a method for identifying substance and testing the purity of a compound. TLC is a useful technique because it is a relatively quick and requires small quantity of material. Separation in TLC involves distribution a mixture of two or more substances between a stationary phase and a mobile phase. The stationary phase is a thin layer of absorbent, usually silica gel or alumina coated on a plate. Mobile phase is a developing liquid which travels up the stationary phase carrying the sample with it. Component of the sample with separate on the stationary phase according to how much they absorb on the stationary phase versus how much they dissolve in the mobile phase. So thin layer chromatography. It is a technique, it is a figure shows how we perform the thin layer chromatography. In the figure, the plate, small plate is which is shown, it is a TLC plate, and always use pencil to mark on the TLC plate, because if you use any ink or any other color, it also travel in the mobile phase. So always remember use pencil, and always run the TLC in a glass jar or any jar which is packed. So if the evaporation of solvent was shown, so it can affect the TLC plate. So suppose that this is the glass jar and you have put the mobile phase in it, and your TLC is this where you mark the three spots. One is the red, second is the blue and green, and put the TLC in the mobile phase, and after some time you see it travels like this. So it is, you just see that it is a TLC plate where I spot the several spots, and after running it travels with the mobile phase. So it is clear what is TLC and what is TLC plate. Preparing of the chamber to a jar, how what type of chamber we want for the development of TLC or to run the TLC plate. TLC chromatography, a thin layer chromatography. To a jar with a tight fitting lid, add enough of the appropriate developing liquid so that it is 0.5 to 1 centimeter deep in the bottom of the jar. Close the jar tightly and let it stand for 30 minutes so that the atmosphere in the jar becomes saturated with solvent. Preparing the plates for development. With a pencil, it is two small notches into the absorbent about 2 cm from the bottom of the plate. The notches should be on the edge of the plate, and each notch should be same distance up from the bottom of the plate. The notches must be farther from the bottom of the plate than the depth of the solvent in the jar. Using drawn out capillary tube, spot the sample on the plate so that they line up with the notches you etched. Question: what type of question is there? What is wrong with the plate shown below? Anything you guess? What is the wrong in this plate showing this? Developing the plate. How we develop the plate? After preparing the development chamber and spotting the sample, the plate are ready for the development. Be careful to handle the plate only by their edges and try to leave the development chamber uncovered for the little time as possible. When the plate are removed from the chamber, quickly trace the solvent front, the highest solvent level on the plate with pencil. Identifying the spot. Visualization. If the spot can be seen, outline them with a pencil. If no spot are obvious, the most common visualization technique is to hold the plate under a UV lamp. Many organic compounds can be seen using the technique, and many commercially made plates often contain a substance which aid in the visualization of compound. Visualizing agent. Some visualizing agents are alkaloid, drag and drop reagent, cardiac glycosides, antimony trichloride, sugar, aniline phthalate, amino acid ninhydrin. Interpreting the data. How to interpret the TLC data? The RF retention factor value for each spot should be calculated. It is characteristic for any given compound on the same stationary phase using the same mobile phase for development of the plate. Hence, known RF value can be compared to those of the unknown substance to aid in their identification. So, what is the RF value? RF is equal to distance from the start to center of the substance spot and distance from the start to solvent front. Means this divided by this RF. Note, the RF value often depend on the temperature and the solvent used in the TLC experiment. The most effective way to identify a compound is to spot known substance authenticate next to the unknown substance on the same plate. In addition, the purity of the sample may be estimated from the chromatography. An impure sample will often develop as two or more spots, while a pure sample will show only one spot. Summary: a TLC plate is a sheet of glass, metal, or plastic which is coated within a thin layer of solid absorbent, usually silica or alumina. A small amount of the mixture to be analyzed is spotted near the bottom of this plate. The TLC plate is then placed in the shallow wool of a solvent in a developing chamber so that only the very bottom of the plate is in the liquid. This liquid or the eluent is the mobile phase and it slowly rises up the TLC plate by capillary action. It is rises with the help of capillary action. As the solvent moves past the spot that was applied, and equilibrium is established for each component of the mixture between the molecule of that component which are absorbed on the solid and the molecule which are in solution. In principle, the component will differ in solubility and in the strength of their absorption to the absorbent, and the some component will be carried further up the plate than other. When the solvent has reached the top of the plate is removed from developing chamber and dried, and the separated component of the mixture are visualized. If the components are colored, visualization is straightforward. Usually the compounds are not colored, so the UV lamp is used to visualize the plate. So that it's for the TLC chromatography, thin layer chromatography. In my next video, we will discuss about the paper chromatography. So if you like the video, please share, subscribe, and if you want more videos like interesting videos like this, so please press the hit icon and please share the videos with your friends. Thank you.